Right, so I don't know if you guys could see, but so
the first one, this is the northernmost one.
To the left of the road up there, you could see the damage
path. The trees
path.
snapped off?
You see the trees snapped off, those brighter areas. And then
Good afternoon, everybody. This is a live extreme weather briefing. We have a lot to talk about, especially the new scientific data that we are analyzing right now from this event on April 5th. You can definitely see the development of these large renegade supercell storms that developed just ahead of the line. And this is on April 5th. It was quite a complex evolution. You could see those two lead renegades developing right ahead of the line just to the west of Troy, Alabama. And then it was followed by about 20 minutes later, yet another QLCS came through. And it looks like there was a swath of damage that passed just to the north of the Gravitron network that was deployed. And we deployed 3 Gravitron sensors. Number 6 was the furthest north. That was about a mile or a mile and a half to the north of Petrey, Alabama. Number 3 was deployed in the middle. Number 4 right down in downtown Petrey. You can see the video from the drone that was also recorded. That is just below my head there. We actually intercepted 2 renegade supercell storms. This is the first renegade. That one had a tornado warning, very nearly produced a tornado crossing just to our north. You can clearly see the rotation. 2 renegades fired out ahead of the QLCS line. This was the first one that we intercepted. We did not deploy any sensors on this one, but then we saw the next renegade that was coming up from the south. That one was clearly the storm. The mesocyclone went right through the town of Petrey. Mesocyclone passed right over the Gravitron network as well. There you could see the storm that was approaching Petrey. 2 circulations are evident, and we're going to break down in detail the detailed radar imagery from this renegade storm that was approaching the Petrey area. It did produce a large damaging tornado that touched down just a couple of miles to the northeast of number 6 that was deployed. But then we came back and retraced the damage path from that tornado that flipped a car about 9 miles to the northwest of Troy. We traced it all the way back to number 6, thinking that the damage that was caused very near the number 6 sensor, about 100 meters to the north of the sensor, was caused by that lead renegade tornado. Here you can see it touching down. Look at the rapid left to right motion, rain curtains zipping by, and this actually turned into a destructive tornado. You can see that little rear inflow jet passing right over number 6. We thought that that was when that damage was caused, but we went back and did a damage survey, and saw that a church had roof damage about 100 meters to the north of number 6 that we deployed. There was also a knife-like tornado damage path that took down trees, snapping them just above the ground. There's the church with the destroyed roof. And we actually figured out that that damage, we believe, was caused by the QLCS that came through 20 minutes later at about 1620Z, 20 minutes after the Renegade storm. We do have the surface pressure data that we believe supports this story as well, and that's what we're going to be breaking down. Let me see if this overlay is working. I have Microsoft Paint on here. Should be able to draw. Oh, yep, look at that. Number 6 right there. I am actually drawing, folks, a new product that I have been adding onto here so I can actually annotate these videos. So this video right here, this is actually the drone footage, and also that's the damage. You can see the damage back behind me as well. That was caused by that grove of trees right around there. Some of that serious damage was caused. There's the roof damage right up on the church. You can see up in the upper right-hand portion. The gravity wave sensor number 6 was deployed on a stop sign just in the front yard of 6. There you can see where the gravity wave sensor was deployed using flex tape, reinforced as well. There you can see the church off to the north. The tree damage right along that swath, right along that tree line. Look at those trees that are snapped off. Anytime you see tree damage that's snapped off like that, just above the ground, that's likely a tornado. Sometimes, though, if you see just an isolated tree that is uprooted here or there, that doesn't require quite as strong of tornadic winds. But after that lead supercell, we dropped south. We deployed 3 pressure sensors or gravitrons in the path of the tornado. They also measure temperature and relative humidity. And I'm going to be breaking down the data as collected. And here you can see the radar. This is the radar data. You can see watch these renegades right there that are developing. There's the Petrey renegade going all the way up. Hook forms, boom, bounded weak echo region, produces a large tornado, continues off to the northeast. And then you can also see back behind those renegades, there's the 2 renegades, the northern one. Here's the QLCS line coming through 20 minutes later. That actually passes the sensor network north of Petrey at 1620Z. The tornado crossed from the renegade, crossed the supercell, crossed the sensor network at about 1558 UTC. And so clearly there was a very complex event that passed over the sensor network. That 3 sensors. The goal is actually to deploy these in a triangle configuration. So you can see that I only achieved a line north and south. This is number 6, the northernmost sensor. The next one down, number 3. One below that was number 4. This was deployed in downtown Petrey. And the Renegade supercell was moving more easterly. It was moving in an east-northeasterly direction. I actually thought there was a chance that it was going to be heading toward downtown Petrey. And the goal is to deploy these gravitron sensors in a triangle configuration with about 0.5 kilometers on each side. I was only able to manage a line out ahead of the supercell, which increases the likelihood of an individual sensor getting a direct hit. But you're not able to triangulate to get the speed and the direction of pressure waves that are moving over the network. But still, as I was dropping south, I thought that supercell was moving in a more east-northeasterly direction, potentially impacting downtown Petrey. And then at the last minute, it cycled, started heading more to the north, and the main circulation, the main meso, went right over number 6. So the rear inflow jet pumping into that developing tornado. A damaging tornado actually developed a couple miles to the northeast of number 6. And then the QLCS came in later. That was at about 20 minutes after the Renegade supercell came through. And that one caused a tornado that knifed right through the gravitron sensor network that is number 6. I'm going to show you the detailed surface pressure data that supports that narrative, that it was 2 storms. It was obviously supported by radar. The lead renegade that passed through just prior to 16Z, that was a large-scale mesocyclone. And here you can see the mesocyclone on approach to number 6. Relatively broad. Usually when a circulation like this has a tornado, you'll see that very tight gate-to-gate couplets right next to each other. This one was actually in the process of cycling. It also had an area of rotation a little bit further south that was starting to die out. That'll show you on the radar loop aloft. This was the new mesocyclone, ramping up very fast. And by definition, a mesocyclone is of larger spatial scale than a tornado cyclone. So this mesocyclone was able to move right over all 3 sensors, recording about a 5 millibar pressure drop, a very laminar pressure drop as well. It was very smooth, not a lot of gravity waves, not a lot of turbulence. It was ramping up, just about to produce a strong, violent tornado, potentially just to the northeast of number 6. You could also see a weak echo region right there. See that hole in the reflectivity? That's a bounded weak echo region within the hook of this renegade supercell. Upper level winds blowing more due westerly, taking all these hydra meteors out of the mesocyclone, a well-ventilated mesocyclone. Also a renegade storm ahead of the QLCS that would approach about 20 minutes later. And we thought that when we first saw that damage that was caused just to the north of number 6, that was actually caused by the renegade storm. We were searching for a debris correlation drop, maybe a little hint of one, but really looking like more of a radar artifact, probably some hail within the core, some differential reflectivity, spike getting picked up. That's probably more of the rear inflow jet into this intensifying mesocyclone, picking up some leaves and some scattered debris as well within that circulation. That is the lead renegade, and we thought initially, because of that report northwest of Troy, and we saw that report to the northwest of Troy further northeast, of that vehicle that was actually rolled over the highway. So we assumed that was a continuous damage path all the way through, but it just wasn't that simple. So I'm going to share with you the debris ball that was caused by the renegade supercell right after it passed off to the northeast. And this was one of the later radar scans, only about 5 miles to the northeast of number 6. You can see this massive debris ball. Here is the highway just ahead of that likely strong tornado. This is exactly where that car was rolled, to the northwest of Troy. You may remember initially when we were trying to intercept this renegade storm, we were initially going to be heading to Troy, dropping down this highway. We would have deployed the sensors out there, would have intercepted, had a direct hit by the renegade, then likely a direct hit by the QLCS. But because that renegade was intensifying more rapidly on approach to Petrey, I ended up changing my navigation, typing in Petrey, dropping down. We deployed number 6, deployed number 3, then deployed number 4 in downtown Petrey and waited for that storm to develop. But then it ended up touching down about 2 miles just to the northeast of the sensor number 6, began cruising all the way northeast, rolled the car, flipped the car just to the northwest of Troy, and continued off to the northeast. But that's the correlation drop that showed you that tornado lifting. Definitely a very isolated correlation coefficient. It's not any side lobing data. The other night I saw a couple posts from some people, weather enthusiasts that were following my Twitter feed there to the southwest of Barwick, and that debris drop looked like it was side lobing, looked like it was inflow, but was actually a debris signature. Ended up putting down a tornado near Thomasville, just to the northeast of Barwick as well. So sometimes these correlation drops can actually mask themselves as more of a radar artifact. In this case, very clear cut. Renegade supercell produced a destructive tornado just a couple miles north of where we deployed the number 6 data impact. So then after the first renegade came the QLCS. That was at about 20 minutes later. And I want to show you this radar data as well before we introduce everything else. This goes to show you, and it's a little bit further away from the radar. This is the QLCS that came through at 1620. So after the renegades were developing, and they developed to the south of the elbow, down out ahead of the bow echo, and then they'd migrate out to the northeast, producing tornadoes right when they'd get about even with the bow, and then they'd get absorbed into the line once the line ended up catching the renegades. But then there were also tornadoes within this circulation, and you could definitely see the QLCS circulation. You could see the bulging RFD up tight There you can see number 6 as well. Perfectly sampled the QLCS. You can also see this bulge right here. You can actually see the bulge in the velocity structure, keeping in mind that it's far away from the radar, and a lot of times these QLCS circulations will be a little bit masked because they are so low in elevation, but you can even see a little bit of a pop in the differential reflectivity, very close to the number 6 sensor. You can even see a little bit there maybe on the correlation drop, but it is so far from the radar that it really failed to pick up the debris loft from the QLCS circulation. But clearly you could see the circulation there. You could see the RFD bulge. You could even see it on reflectivity. You could certainly see that clear cut, that moat with the rear inflow jet. So it was obvious a QLCS type of a situation that came through just a little bit after the lead QLCS. And let me zoom in a little bit closer to also show you more in depth the sensor network on the QLCS pattern. So here you can see number 6. Then the next sensor, number 3, number 4. And so what I'm going to show you next in the data is that when the QLCS came 20 minutes later at 1620, the violent pressure dip was only registered by number 6. And here you can see a bit of a rear inflow jet. You can almost see the reflectivity blob, a little bit of a bulge within the QLCS. But that pressure dip was not registered by number 3 and number 4. However, the Renegade, as it passed over the network, the mesocyclone being on the order of about 10 kilometers or so, that pressure dip was measured by all 3 of these sensors. And I'm going to show you that next in the data. Zoomed in radar. Again, here was the Renegade, number 6, off to the north of Petrey. Here is the bounded weak echo region we were discussing just as that Renegade supercell is ramping up. So we clearly sampled 2 events, the lead Renegade storm and also the QLCS tornado as it passed through afterward. And I'm going to show you this now in the data. This is the pressure data that was measured by the 3 units. The yellow line, which is the lowest, that is number 6. That was the furthest north pressure sensor. So this dip right here, that was the Renegade supercell passage. That's the mesocyclone passing over the network of 3. This was the deployment relatively close to the event. Very smooth or laminar pressure dip all the way down. It's about a 5 millibar pressure dip and then back up. Remarkably smooth or laminar. And usually when we see such a smooth dip like that, we've actually never seen one this smooth. That likely means that there's not a tornado on the ground and that it's more of a mesocyclone aloft that is passing through. But look at this dip, the second one, about 20 minutes later. That's the QLCS event, the line that came through that caused a lot of damage about 100 meters to the north of number 6. Notice how it's not included on number 4 or number 3. Number 4 being the one in downtown Petrey. Number 3 being the middle sensor, and number 6 being the furthest north that very closely sampled that more compact QLCS vortex that wasn't necessarily coupled with the large-scale mesocyclone. The large-scale mesocyclone, though, that dip was measured by all 3 sensors. A very laminar pressure fall, very smooth, not being marked with this waviness or gravity waves going all the way down. Mark is still analyzing the pressure whipsaw in the second portion of that data zoom. But the larger scale mesocyclone passed over all 3 sensors, recording roughly a 5 millibar pressure drop, about the same. And then the QLCS came through 20 minutes later with a pressure drop only on one of those sensors, the northernmost sensor. So now I want to zoom in a little bit on some of that data. This is the data zoom. And this is the first dip. This is the Renegade dip. All 3 were measured, with number 6 measuring the greatest fall. That's because that was closer to the heart of the mesocyclone. It was also near the heart of a developing low-level mesocyclone that would put down a strong, potentially violent tornado about 1 or 2 miles just to the northeast of sensor number 6. This was the middle sensor, not quite as much of a drop. That's sensor number 3. And this is the one in downtown Petrey. Not nearly as much of a drop. All of these, though, roughly about 5 millibars. Roughly a 5 millibar drop that was sampled by all three of those pressure sensors. That was the first dip. The Renegade, that was a larger mesocyclone also. So now let's take a closer look at the second dip. That first dip was caused as a very well-defined mesocyclone. A renegade supercell passed over all three of the datas. And then that tornado touched down just to the northeast of the gravitron sensor. Classic renegade supercell. Didn't quite have a debris signature as it passed over number 6, but it did just to the northeast as it crossed the road just to the northwest of Troy. Very interesting. So now let's take a look at the second one, which was the QLCS regime that came through. There's the radar data. Obviously, you can see just that tiny little inflow notch. You can see just a little bit of a bulge in the RFD structure. Inflow getting pulled in on the north side of that. You can also see differential reflectivity showing likely some leaves, tree branches getting lofted. You can also see the bulging gust front as well, the shared gust front pulling in that inflow all the way back behind. And then you get the occlusion on the backside. Drastically lower reflectivities on the backside as the rear inflow jet came in. That's the QLCS that we have been talking about. A little bit of a shallower vortex. I bet that the damage survey, National Weather Service Mobile, is probably just going to have that as one big damage path, only associated with that Renegade. But clearly, our data supports that the QLCS circulation that came through was a separate vortex. That's also the damage that we analyzed. So this is a zoom in of the pressure fall. You expand the pressure fall. And notice how these gravity waves are evident. Up, down, gravity waves all the way down to the pressure minimum. The pressure magnitude overall of the fall was about 5 millibars. And then you have a dramatic rise. This is a pressure whipsaw. Rise, down, dramatic pressure fall, and then back all the way up. That's about what you'd expect. You can see the gust front passage as the pressure rises up to a max. Then it dips as the tornado vortex just behind the gust front is ramping up. It's moving into a fluid, compressing that fluid in a wave-like configuration, having gravity waves. So that's one thing that we've noticed with our pressure falls that are associated with a tornado on the ground is we have this noisiness. We have this gravity wave signature that happens all the way down to the minimum. Even these pressure whipsaws, a sloshing effect that'll happen with the atmosphere. Then it smooths out as the vortex passes. Clearly, this is a signature that would be associated with damage being caused. It's a lot more noisy, a lot more violent of a pressure fall as well. Whereas the initial passage of the QLCS, or of the Renegade storm, was much more laminar. Obviously, that was a mesocyclone, a deep mesocyclone on the order of about 10 kilometers in width, passing over the sensor network. Here's another look at that pressure whipsaw from number 6, and notice how it's not included a little bit. It is included just a little bit at number 4 first, kind of catching a glimpse of the developing tornado behind the line, but really evident here. Look at these waves too, gravity waves, a noisy descent all the way down. That's the opposite of a laminar pressure descent, and that, at least in our limited experience with the gravitron network analyzing these pressure traces, a more noisy pressure descent like that is associated with a tornado on the ground, and then bam, violent pressure whipsaw correction just after the tornado passed by. And the sensor in blue that was down into downtown Petrey didn't even register the QLCS tornado that went by. So I think this is pretty unprecedented data to show the Renegade that passed through. We thought that initially that was caused by the Renegade, but then upon deeper analysis of the data, it's pretty obvious that our data actually supports the Renegade not quite yet having a tornado on the ground. Here you can see this very low base associated with the storm. This is from the Dominator drone looking north at the Renegade. You can see these clear slots that are punching in to the backside of the mesocyclone. Clearly there's a low-level pressure fall that's forcing this cross isobaric flow from the rear flank downdraft across isobars, across the mesocyclone, and that's what causes the mesocyclone to tighten up into the tornado vortex. It's coupled with the mesocyclone above, but this large mesocyclone passing over the three sensors, number 6 deployed right there, number 3 deployed right there, and number 4 deployed in downtown Petrey, was just caused by this large-scale mesocyclone passing over the network, leading to a modest 5 millibar pressure drop, a smooth drop, very laminar drop as well. Laminar, smooth. So it appears that the tornado was not quite on the ground right as it passed over gravitron number 6, but then became a large destructive tornado about 2 miles to the northeast of the sensor network. That's what I mean when I say that this is a game of inches. I thought maybe this was on the ground looking at the drone because you could see some spray here. A lot of spray, a lot of evaporation. It's right underneath what appears to be the tornado cyclone that's beginning to intensify, with the clear slot surging just on this side, the south side of the developing tornado cyclone. So I thought that that spray is what caused the damage right near the gravitron sensor. It still is possible that is what caused that damage up there. Number 6 is very close on that north-south road on 31, just to the north of Petrey, that maybe this spray was actually the tornado. I bet that the National Weather Service Mobile Damage Survey is going to show that the Renegade produced a long-track tornado that touched down just to the north of Petrey, rolled that vehicle to the northwest of Troy, and then continued off to the northeast. But it's possible that this wasn't even a tornado on the ground here. It didn't touch down until about 2 miles to the northeast, and that actually that damage that was observed just to the north of gravitron number 6 was caused by the QLCS event that passed through next. And that would be consistent because there's a lot of gravity waves. It's more of a noisy descent, a lot less laminar. Definitely would be supportive of more of a deeper mesocyclone coming through. So here is the Renegade developing. I was using this radar a lot when I was trying to look at that radar loop. But there is the Renegade that produced a long track tornado northwest of Troy, kept going, got absorbed by the line, and then the QLCS came out. The initial Renegade that we got on was up here. That one went tornado warned, then dropped down to the next Renegade. Notice how they would produce right when they get to the elbow of the trailing QLCS, just before getting absorbed by the QLCS pattern. Clean inflow as well up into that storm. That's how we dropped down to Petrey, Luverne area. I did hear that Dr. Biggerstaff with the University of Oklahoma actually sampled the QLCS that came through Luverne. I talked to him the morning after our intercept. He said that he actually sampled one of those QLCS tornadoes within the line, moving through Luverne. Quite interesting. So that is our data so far. Pretty interesting data collection. There is the lead storm. That was the first Renegade. Nearly put down a tornado. I also want to show you the mesocyclone loop. There is the mesocyclone coming through Petrey. And obviously it's a deep mesocyclone. Clearly very well connected and coupled to the updraft of the thunderstorm. Obviously that's a deep mesocyclone. Very capable of producing about 4 to 5 millibar pressure drop across all three sensors. Large enough scale on the order of about 10 kilometers. Also very capable of dropping a destructive tornado just a couple of miles off to the northeast as well. So that was the mesocyclone that caused the initial laminar smooth pressure drop, and it was followed by the QLCS event that was that produced a much more noisy, more dramatic pressure fall that was only registered by number 6, associated with a much more compact pressure gradient at the surface, and that's why we sampled the damage just to the north of sensor number 6. It also goes to show you that this is absolutely a game of inches, miles as well. That is certain. This is obviously a game of inches and miles, where especially when you're deploying these sensors in the path of tornadoes, you have to time the maturation of the tornado. You have to deploy the sensors. You also need to document the tornado. You need to launch the drone as well. All of those things happening while the adrenaline is pumping. So that goes, and the goal is to get the Gravitron network deployed as a triangle with about 0.5 kilometers on each side. But our storm chasing mission, number 1, is about this science project. It's always about the science. Number 2, it's about the live streams, warning people in the path of these storms. And number 3, it's about capturing video as well. So interestingly, we thought we had a direct hit on the Renegade supercell. We thought it had a tornado on the ground, but it ended up being the trailing QLCS. This was the first mesocyclone that came through. That was the loop that I just showed you. That shows the mesocyclone, a laminar descent all the way up, not really capable of a very violent surface pressure gradient. However, the second QLCS vortex that came through, much more compact, not really registered by number 3 or number 4, but a much more violent descent characterized by gravity waves all the way down, a pressure whipsaw on the backside. So what we're definitely showing here is that these Gravitron networks, especially if we had a dense network of these things across the entire country, that you'd be able to use the surface pressure field to paint a story and to supplement the radar data to really paint a more accurate representation of what happened, especially with these complex evolutions where you have a renegade supercell that passes through first, and then you have a QLCS tornado on the backside. Both of these sensors deployed, and all 3 sensors mounted using flex tape to the sensors. Thank you, flex tape, for powering our science mission. Thank you, Facebook subscribers, for making this science possible as well. I do plan an exclusive live Q&A to go over this data, the surface pressure fields associated with these complex evolutions of tornadoes, Renegade, followed by about 20 minutes later, the QLCS tornado. We could also use drones to try to land in the path of the tornadoes and drop a sensor right in the path of an approaching tornado. That might be a better option, because then we don't have to depend directly on the map as well, or on the road network, and on deploying these in the path of a tornado. So quite a successful data set measured on April 5th, and we're going to be heading back out once again. It looks like Monday through Wednesday look like pretty substantial severe weather days. I'm going to be teaming up again with Captain Vanover as well on this one. Looks like Monday through Wednesday, potentially historic tornado outbreak again across Tornado Alley. So Tornado Alley is coming alive in a big way next week. Multiple day severe weather event, Monday, Tuesday, Wednesday. I'll be back out there deploying Gravitron sensors, launching our racing drone as well. And the goal again is to try to get a triangle. If I just got a gravity wave station 0.5 kilometers off to the east, instead of dropping into downtown Petrey, thinking that tornadic circulation was passing off to the due east, then we would have had the triangle 0.5 kilometers, and then we could assess the direction that these pressure waves are moving, how fast they're moving, and even assess the speed and direction of the QLCS tornado that impacted number 6, causing roof damage to a church there, as well as snapping trees right along the tree line on approach. And that pressure whipsaw was only measured by number 6, and it was not measured by number 3 and number 4. So thank you everybody for joining me for this weather report. I am going to be breaking down the Monday through Wednesday trough ejection in great detail. I'm going to be heading out toward that direction tomorrow to storm chase those 3 days in the Dominator 4. We'll be active once again, full blown storm chase mode. Be sure to sign up for subscriptions and notifications, of course, for those live updates, because I am going to be going live big time coming up during this event. But that's a breakdown of our latest scientific mission from April 5th. The day after that, we did deploy the sensors as the tornadic supercell was approaching Valdosta as well. If we waited in Quitman and then blasted southeast on that road out of Quitman, we likely would have intercepted that tornado directly just southeast of Quitman. Instead, we dropped down to the Florida Panhandle due east, back up again on the east side of it, deployed 3 sensors, and then the supercell tornado lifted about 6 miles to the southwest of the Valdosta Airport, west-southwest of I-75 as well. So we missed that deployment. The Barwick tornado, I actually got pulled over for my taillight being out in Morven. That caused us to miss the deployment on that tornado. Potentially prevented us from driving into that tornado after dark as well, just to the northeast side of Barwick. That was an interesting radar case where it almost looked like side lobing, looked more like inflow, clean access to the inflow. But in the end, there was actually a debris ball that was nested within those low correlations that would be consistent with a radar artifact. I was definitely confused in real time myself as it was happening, but realized quite quickly that that was a tornado near Thomasville, approaching Barwick, and then heading off to the northeast. So there you can see it, everybody. Successful deployment for this mission. Of course, this scientific analysis isn't for everybody, especially for those with the shorter attention spans, but we do like to do deeper dives into the scientific data over here at Team Dominator. And there you can see the data that we collected. A complex evolution of a renegade supercell followed by a QLCS pattern that was actually what produced the tornado. So thank you, everybody. Stay tuned to my weather reports. I'm going to be slinging live weather briefings along with hundreds of my friends coming up here leading up to this big event, Monday through Wednesday. Megatroph ejection into Tornado Alley as it comes alive in a big way next week. Never stop.